Hi, so yeah, Seb says my name is Ara Pulido. I'm an engineering manager at Bitnami, and for the next few minutes, what I'm going to be talking about is how you can use cloud managed services in your Kubernetes application using something called the service catalog. So what I'm going to do is I'm going to spend the first 15 minutes explaining what the service catalog is, and then we are going to see 4 examples, hopefully. One of them breaks sometimes because of a bug, so let's see if it's 4 or 3, but hopefully 4 examples of applications that are using cloud managed services using the service catalog. For those examples, we are going to use Helm Charts. Who is familiar with Helm around here? Okay, quite a few. If you are not, you're going to be able to follow along if you know how you use YAML to describe Kubernetes objects, because it's Helm Charts, which is the packaging system. Helm Charts is basically YAML. It looks like YAML with Go templating in between. So you will be able to recognize all your deployments, services, everything. So first of all, who we are. Let's get rid of that. Yeah. So Bitnami, you may know us as our work on packaging applications. So we have a catalog of more than 200 applications on the different marketplaces in the clouds. So if you want to run MySQL or Ghost or WordPress or whatever these popular open source apps in one of the public clouds like AWS or GCP or Azure, you can go to their marketplaces and you can say, okay, I want to launch an instance of MySQL, this size, etc., and that's working out of the box. That image may come from us. So this work of packaging applications, we do that as well in Kubernetes. The way we do that is that the same catalog, we have containers, packaged as containers, Docker containers, that many of them are non-root, so you can run them in OpenShift, for example. And we also maintain a lot of Helm charts. So this packaging system for Kubernetes, there is a stable repo on the Kubernetes organization. Many of them are maintained by us, and we maintain some others in our own repo as well. So all this work of application packaging and application deployment, we also contribute to some open source projects on this space. So some of them are Kubeapps, which is an application dashboard for Kubernetes applications. We are going to see Kubeapps throughout the demos. BKPR or kubeprod, depending on how you want to call it. It's a monitoring, ingress, logging stack that we maintain that you can put on top of your cluster based on Prometheus, Elasticsearch, all the basic stuff. Seal Secret, that Alexis already mentioned. Kubeless, which is a serverless framework for Kubernetes, and others. So to start with the talk, why would you need managed services on Kubernetes? So you already use Kubernetes to orchestrate your application, your containerized application. You have a stateful set, so if you need a database, you can deploy it there. You can deploy as many services as you need in Kubernetes. But one of the benefits of cloud-native and cloud-native applications is also being able to use these services that are maintained by the clouds. So you can focus on what makes your application. So for example, if your application is a PubSub queue or a database or, bucket storage, things like that, obviously you can deploy those services yourself, maintain it yourself, take care of backups, HA, all these things. But you can also use one of these services that are provided by the clouds. You pay for them. Those are paid services. But in return, you can have all these backups, HA, all these things, multi-region, taken care for you, and you can focus on what makes your application. So one of the problems with this right now in Kubernetes is that in many cases, this is completely disconnected from one another. So how would you do that usually? So you want to provision one of these services, and maybe you have to talk to to your operations team to provision that for you. Or if you have the right permissions, you can go to these cloud UIs and request one of these instances. Or maybe you can use the CLI or APIs to connect your CI/CD with these tools. And then you have to connect that back to Kubernetes. So you have to possibly create a secret in Kubernetes with your authentication, with all the information to connect to these services that then you can use with your application. This is all good. You can do this, but the problem with this is that it breaks the declarative model of Kubernetes. Basically, the declarative object model is that you describe your application as Alexis explained with GitOps, and Kubernetes is going to be doing the right thing. Instead of saying to Kubernetes, do this first, then this second, in an imperative model of tasks, you describe your application, everything that is your application, including your databases, including your services, and Kubernetes is going to do the right thing for you. So the service catalog is basically this. It tries to bridge these two walls together. So the definition is that a declarative Kubernetes API extension to discover and use services using something called the Open Service Broker API. So what is the Open Service Broker API? It's a spec, it's a standard, it's not an implementation for these purposes, for cloud, so for service providers to describe the services. It was first created for the Cloud Foundry, but now has implementations also for Kubernetes and OpenShift. It's a very simple API. It has not that many objects, so I'm going to go quickly through it. This is more or less how it looks like. So these are all the objects that are available. So on the bottom, you have Service Broker, which is the abstraction of a service provider. So it could be GCP has its own broker, AWS has its own broker, Azure, etc. On top of that, you have service classes, which are the different services that these brokers provide. Could be, I don't know, Azure MySQL, or Google Storage Bucket, or AWS RDS. All these things are classes. On top of that, you have service plans. So each of these classes needs to define one or more plans. And the plan is basically the abstraction of a tier of these services. So for example, for MySQL, you may need, for development, you may only a very small instance with just one core, very low memory. But then you go to production and you need a bigger instance. Obviously, those represent different tiers of these services that price go up, obviously. And this is represented on the Open Service Broker API with a service plan. Up to that level, so service broker, service class, and service plan, is as a cluster level. So those are cluster level objects. So this is changing, but right now it's like that. So you need it has to be cluster admin permissions to create those objects, but then they are available for the rest of the users of the cluster. Service instance and service binding are namespace objects, and these are the objects a user, that said an application developer, for example, has to create in order to use these services. So when you want to have the broker to provision an instance for you, you would create a service instance object that would talk to the broker and would do magic for you. And then the service binding is that connection between your application and the instance. In the case of Kubernetes, that takes the form of a secret that then you can use in your application. So the important bit of the service catalog is an implementation of this standard, is that it's a declarative Kubernetes API extension. Right now, it doesn't use CRDs. It uses API aggregation. There is a special interest group in Kubernetes focused on the service catalog, and they're discussing whether they have to move to CRDs or not. But right now, it's an API server. Just to put a couple of examples of how different implementations follow the same spec before we move to the demo. These are the cluster service broker objects for Azure and GCP. And you can see that it looks like a Kubernetes object. It's like everything. It has an API version. It has a kind. It has a metadata with a name that it's mandatory. And then it has a spec. And the spec is very simple. You just have a URL that it's the endpoint to talk to the broker, and some auth information to connect to endpoint. So obviously, if you want to use any of these cloud-managed services, you need to provide your credentials to that service so you're billed correctly and you're using your account. But you can see that those implementations are very different. So in the case of GCP, if you see the endpoint, it's an endpoint on your GCP project. So the broker in GCP is running on your GCP project directly. In the case of Azure, if you can see that, it's a service, a Kubernetes service. So the Azure broker gets deployed on your Kubernetes cluster. So if you want to use Azure, you have to deploy the Azure broker in your cluster. They provide a Helm chart. It's easy to deploy. So, but yeah, it's an example of two completely different ways of implementing the same thing, but following the same spec. The way it works at a cluster level, so once cluster admin creates cluster service broker, it will try to talk to that endpoint. And if it's successful with the auth that you've given, it will retrieve a set of cluster service classes and a cluster service plans that they will be created in your cluster, and it will be available from now on. So we are going to move to the demo. So before moving to the demo, I'm going to explain a couple of tools that we are going to see throughout the demo, apart from kubectl. These are Kubernetes objects, so you can use kubectl as any other object. But we are also going to use svcat, which is a CLI tool that helps you a little bit with the service catalog. It allows you, so you can do svcat get brokers, get classes, get plans, instances, etc. And it provides a better output, so it's easier to read. But also, it allows you to provision instances and create bindings in an imperative mode. So you can say svcat provision, MySQL instance, foobar. Benefit of that is that it's a very good tool to do testing while you're creating these services instances. So you know if you're using the right parameters, you can do quick tests if everything goes well. We are also going to be seeing a little bit of Kubeapps, which is an application dashboard for your Kubernetes cluster, because it has service catalog integration, so it's going to allow us to see easily what's going on our cluster. Cool, so let's switch to the demo. So I'm running a GKE cluster, 111, with 5 nodes. This could be GKE, this could be Azure, this could be bare metal, doesn't matter. Here I'm running the service catalog. So you can see there is a API server, and the controller will be doing the reconciliation loop with this. I have a couple of brokers deployed here. One is the GCP one is the Azure. Both are in ready status, which means that we have already doing this, talking to the endpoint to retrieve classes and plans. So if I do svcat get classes, I should get a list of all the classes that are available for me. Just an example that this is just a Kubernetes object. I can use kubectl to get the same information. So Okay, looks okay. Okay, this is Kubeapps. So Kubeapps, in Kubeapps, you can see the applications that you have deployed as Helm Charts on the different namespaces that you have access to. This is completely authenticated, so it's using my account in this case. You have a catalog of applications coming from different chart repos. You can add your own chart repo. You can remove chart repos. So if you want to focus only on the applications that your team is supposed to be accessing, you can do that as well. And it has service catalog integration here, so you can deploy a new instance in an imperative mode from the different classes. The broken icons on the Azure classes is reported upstream. They're fixing it, so that's good. So this is going to be half-live demo because there are things that I have pre-provisioned before starting. Reason being is that some of these services take a while to provision. Depending on the broker, depending on the service, it can take from 1 minute to up to 10, 15 minutes in some cases. So obviously we don't have time. So first example is we are going to see, so we are going to be moving from imperative mode towards more declarative at the end. So you can see everything, how you can move from doing these things imperatively to move to a completely declarative model. So in the first example, what we are going to see is a WordPress chart, so to deploy WordPress, that uses as an Azure MySQL database. That Azure MySQL database I provisions through the service catalog. It's here. It said that it's successful. Everything is fine. It's a basic tier, so it's a cheap one. And I can create a binding from here directly. So this is usually fast. So it's already here. And you can see what it does when you create a binding is create a secret to connect your application to it. And this is the tricky part with the service catalog. The secret schema is dependent. There is no standard. It's dependent on the broker and the service. So you need to know beforehand the schema of the secret that the broker is going to provide, so you know how to connect your application to it. So this is, in the case of Azure MySQL, this is how it looks like, this secret. It has a database, host, password, etc. And again, this is specific to Azure MySQL, so you cannot trust that if you provision a MySQL on RDS on AWS, it's going to look the same. It's not. And this is one of the things that CGAP's group in Kubernetes is trying to answer how to improve this. Because I know how that secret was going to look like, I've modified slightly the WordPress stable chart, the default chart, and I'm going to explain the modifications in a second. But let's start. And this is the one that may break. So if it breaks, it doesn't matter. I'm going to explain it anyways. So this is a WordPress that I modify, and the way I modify. So in Helm, apart from having the YAML with templating, you have a values.yaml file to provide those templating values by default. So let's call it WordPress Zurich. And basically, what I'm going to say, okay, this is the modification that I made. So I've made some modification to the deployment. So I can say, okay, this is going to use an Azure SQL database. If I put this at true, and this is the name of the secret that contains the information about how to connect to that instance. And I'm going to say that not to deploy a MariaDB. The default chart deploys a MariaDB as database because I'm going to use Azure instead. So I click on submit. It didn't break, so that's good news. And it's going to start deploying. So while this is deploying, I'm going to explain how this chart looks like. So this is the chart. This is how a chart looks like. So it has some requirements. So it has a chart.yaml with some default information like the icon, the values.yaml that we just saw, and a set of templates. So in that template, you have a deployment here. So as you can see, this is a normal deployment YAML with some Go templating, as we discussed. So basically what I did is to say, OK, where do I get the connection to the MariaDB host? So OK, if my values.Azure SQL enabled is true, then you're going to get it from a secret called secret, which we pass the value of the secret. And the key is hard-coded here. I knew it was going to be host because I knew the schema of that one. So I say, OK, in this case, it's host. For the port number, same thing, but port. Database, same thing, but database, et cetera, et cetera. So because I knew the schema, I could prepare my application for that schema. Let's check how this is going. OK, it's not ready yet, probably because of the internet. OK, but it's almost there. So as you can see, it found a MySQL database on the host that I provided in Azure. It connected to that one using those credentials. And it created the needed database. And hopefully that's now ready. So it's deployed, so I can go and check. And it has a WordPress ready using Azure SQL. Thanks. So the second example is very similar. It's same thing, but this one is already. But the difference is that in this case, I didn't have to modify the default chart, the stable chart that it's upstream. So in this case, it's using GCP. I provision, and the reason why I did all of this, this is for Chart Museum. Chart Museum is Helm Chart repo that you can deploy, and you can use local storage, but you can also use Google storage. Amazon, it has a lot of backends available. In this case, what I did is using GCP bucket storage. So I created an instance using the service catalog, a binding. And the good thing about Google Broker, aside from bugs that it has, it's that it returns you the information to connect to it in the JSON file that everybody using GCP expects. So it's always the same schema. In this case, in this key, in the private key data, I have a JSON that has all my connection information. Because it's the full thing that people expect in GCP, for example, the Chart Museum Helm Charts, the full one, is already ready to be used. So the only thing that I had to do is already running. And the reason why it's already running is because I use this particular Chart Museum to deploy my special WordPress. So it's a little bit meta. But if I click here in upgrade, I can see the values that I used for that particular deployment. So as you can see, it's using Google, particular bucket that was created by the service catalog. And here I will say, well, this is the default. I didn't make any modifications. This is the chart that you can get from Kubernetes/charts in GitHub. So you can tell it, OK, I'm going to use GCP, my credentials are in a secret, the name of the secret, and where is the JSON that we know how to use. So this is the default Chart Museum. So as you can see, it's already there. This is the default one. And somewhere here, you have the way to connect to that GCP. OK, so up to that example, everything is a little bit imperative. So there was a lot of benefit because I still had to create those instances first, then the bindings, and then connect. Yeah, the secret was created automatically. It's a little bit better, but it's not ideal. So we are going to see the last two examples, something a little bit more declarative. So the first one is a min stack. So basically Mongo, Express, Angular, etc. In the case of you already have a Mongo instance, you have a Mongo instance that you have already provisioned by someone else, or because it's multi-tenancy, and you want to use that one in your application. So in this case, you have already an instance that someone has provisioned for you, but you don't have a binding. You don't have. You want to make that happen automatically when you deploy your application. So let's use this example. This is a min stack on the Bitnami repo. And hold on a second, because I didn't copy, and I don't know it by heart, the name of the instance. Let's copy this. I'm going to deploy it. I'm going to leave the default name that gets generated for me. Let's put a load balancer so we can see easily the results of this. I'm going to say no to install MongoDB, same case. I could do that. I could use MongoDB in my cluster, but I don't want to do that because I have external database. So that external database is an Azure database. So this is already here the type of the broker, and I only have to give the instance that was already provisioned. So I click on submit. And it's going to start deploying, but look at what is going to happen here. So on the Mongo instance that didn't have a binding, it has been created automatically when I was deploying the application. And it has a secret associated with it. How it's going to work on the chart. So this is the way it's going to work. Is that if you can see on these templates, apart from the deployment that we've seen it, I also have a MongoDB binding.yaml. So I have created that object as part of that deployment. And if I look at the YAML, it says, OK, if you've given me a service instance name, I want to create this binding, and with this instance name reference, and a secret name that I'm going to generate. And everything happens. It's part of my application declaration. It's part of how I declare my application, not disconnected from that. So let's see if this is how this is going. So you can see that, again, this is working. It's using Mongo in Azure. And this is obviously an example application that it's a stack that you can reuse to do your own application. Any questions so far? OK. The last example is going to be a fully declarative example where I don't have an instance, and therefore I don't have a binding. I just have my application declaration that I want to create all of that. So in that case, it's going to be, I think, Ghost. No, catalog, sorry. So this is a Ghost Helm chart created by Azure as an example for the broker. And that one creates everything for you. So you don't have to. It's a good example of how you can create your application to do the same thing. I don't need to change any of this because it already says that to not create. It's basically using the Azure. And it's going to start deploying. This one, we are not going to see the result because, again, this takes about 10 minutes to provision, but we can see something that it's the the magic of Kubernetes, where the reconciliation loop keeps trying until it succeeds. So we can see that it started provisioning MySQL in Azure automatically. And this is where the magic happens. This instance's provision is going to take about 10 minutes. So the binding, the object, was already created. So the service catalog controller already tried to create that. And it returned an error saying that the instance is not ready. Obviously, I cannot create a binding if the instance is not ready. But the thing is, it's going to keep trying until this instance is provisioned. And then the controller will say, OK, the instance is not ready. Now I can create the binding. And same thing for the deployment. So let's clear this a bit. So you can see this is the ghost pod that was created as part of this deployment. And it says, OK, I cannot create this. If we describe why, OK, let's reduce this a little bit. But basically, if you read here, it says, OK, the secret that you already passed me is not available, so there is a configuration error. That secret is going to be created once the binding is ready. That is going to be created once the instance is ready. And that will work on the reconciliation loop. So again, once the instance is ready, the binding will be created. As part of the creation of the binding, a secret will be created. And then as part of that, the general Kubernetes loop will be able to create this pod. Again, the way, and this was fully declarative. I didn't have to create anything beforehand, just to make sure that the service broker are correctly configured. And you can see here, this is the ghost Helm chart that we use. This is on the Azure GitHub. Everything here is on GitHub. And you have an instance here. So it will create the service instance for you with some parameters specific to the broker. It will create a binding for you. And then the deployment will do the same thing as we already seen, of using that information from the key. Same thing, because they know how the secrets look like. And yeah, that's it. So just some takeaways. Open Service Broker is a standard spec. It's not an implementation. The service catalog is an implementation for Kubernetes. It's run by the SIG service catalog. And obviously, declarative is always better. Thank you.